Hi everybody, and in this demonstration I'll be giving an end-to-end example on how we can work with Azure Cosmos DB through Databricks by utilizing a Spark connector. Now, Azure Cosmos DB actually offers API support for a multitude of different connectors. One of those is a MongoDB, and that is the main API that we'll be working with today. And what I'll be doing in Databricks is I'll be uploading that data that we'll be working with into a Hive Metastore, which will be then used as a reference point where we will connect our PowerBI through something called a Partners Connect service in Databricks, which is only available in premium plans for Databricks, so something to be mindful of there. And in the case that you want to learn more about Cosmos DB, one of my colleagues, Mustafa Branch, has a very useful series that can be found in the official Cosmos DB YouTube page. And I will use it, I will reference that in the description below. And I highly recommend you to check it out. I think it's a very useful place to start if you have never worked with Cosmos DB before. So moving forward from that, I think it's maybe useful to start off again with an architecture of what we will be doing today. So I've created a Python application that actually web scrapes Google for the latest weather information for a location that I specify. This will then be used in our Azure Cosmos DB resource that we will create in our Azure portal. And this will obviously reference the MongoDB API. And through the use of a service endpoint, we will connect our Databricks account or workspace, which will be created in a virtual network through VNet Injection. And from there, we will be moving that data into our Hive Metastore, which will then be utilized through PowerBI. And I think this architecture really encapsulates or helps you understand where we are throughout this entire tutorial. And it gives you a sort of a visualization on some of the work that we'll be doing. If you're ever confused on where we are in the steps, I would highly recommend you reference this architecture in that point. So if you head over to your Azure portal and click on Cosmos DB or create the Cosmos DB resource, you'll be landing on this page. We're going to be working with the MongoDB API here. So we're going to create that. We're going to create a new resource group, or actually we're going to utilize an existing resource group, but feel free to create one if you, as you see fit. We're going to use Cosmos DB Databricks here. For the account name, we're just going to label it Cosmos DB Analytics Connector Mongo. And we're going to put the region or the location closest to where you are if you want. So it would be Canada Central for me. And over here, you'll see that there's two capacity modes. So let's talk a little bit about them. One of them is provision throughput. And provision throughput are best for cases where you may have predictable performance. And you can basically specify or configure something called request units. Request units is basically a metric that is used that takes into account memory, CPU, IOPS, and out operations, and gives you a set price for that. And there's another mode called serverless, and this is for workloads with maybe intermittent or unpredictable traffic. You don't have to really specify any metrics such as request units or anything like that. It will basically scale up as it needs to for your needs. So this is, in our case, we're going to need serverless as it requires a lot less configuration. I'm going to keep it there, head over to next. So global distribution. So something that Azure Cosmos DB offers is very high availability. And by turning this on, you can actually enable your data to be replicated over as many data centers as you need. And this process is seamless. We can enable this and select the availability zones we want our data to be replicated in. We can go through networking. And even though we're actually going to be using a service endpoint from a virtual network that we're going to be creating, we're going to leave this as is for now. We're going to go to backup policy here. We just keep it as is. For the tags, we keep it as is. Click and review. The validate is successful. So now I'm going to be creating this resource, and it will take a few minutes for it to be deployed, and I'll be back with you when it's deployed. So the resource has been deployed now, and if we go to the resource itself, you will see that you're introduced with a quick start for the different, maybe if you want to connect to your .NET application, Node.js, whatever the case is. Obviously, every use case is different. For us, we'll be requiring Python, but instead of going there, I'm going to take you over to the connection string here. So this is many of the inputs that you're going to need to facilitate the connection in any of your applications. And what we're really concerned with here is the primary connection string, because this is what we're going to be using as the string that we'll be referencing when we're trying to authenticate ourselves. But more so than that, if we head over to Data Explorer, we're going to need to create, obviously, we're going to need to be creating the database as well as the collection. A collection is just another term for tables, if you worked with relational databases before. And if you go on new collection here, you just click on that, click on new database. We're going to write this as maybe testing Cosmos and enter here. And then we're going to be creating a collection right after that. Let's give it a second for it to load. Yeah. All right, great. So now over here, what we can do is we can write, there's 3 dots here. We can click on that new collection. And now we can specify the table name or the collection name. So we'll just label it testing Databricks Cosmos. We can put uncharted here. And like I said, if you are not familiar with what this is, you can either click here and see the video that is in the link in the description below, where my colleague has a really in-depth explanation of what these things are. And now Analytical Store, we actually have something called Azure Synapse Link. This is not something that we're going to be doing today, but this allows seamless integration with Azure Synapse Analytics. And this allows for CosmosDB to seamlessly sync to an analytical store that you can use either Apache Spark pools or you can use serverless pools to actually work with the data from Azure Synapse. This is not something that we're going to be super interested in right now. Maybe this is for another video. We're going to be focused on Databricks. So this is the configuration that we're going to need. I'm going to click on OK. And this is going to take a second for it to create that the collection within the database. So now we have our collection, and inevitably what we want to do is start feeding data from our application into our CosmosDB resource here. So there's a few things that we're just going to have to know and note down. That is, one of them is the database name, the collection name, and the connection string, which can be found in the settings, connection string. Now you can use your primary or secondary, it really doesn't matter. In this case, it would just I'll be using the primary connection string. You can copy that to the clipboard here. And then if you go to our application, what we can do is fill obviously all these parameters. And what this application does is it will look over a given city by web scraping Google and return the JSON objects, which will be formatted to extract the data relating to the weather, if it's partly cloudy or not, the weather conditions, the time, etc., etc. And then it will load it to Cosmos. If the load is successful, it will say load to Cosmos DB successful. And now that I'm thinking about it, maybe it's prudent to just add this here to let the CPU sleep for maybe a second, so it's not just constantly feeding it. All right, great. So now if we run this, now if it's successful, it should say load to CosmosDB successful every run. And this is continuously going to run. It'll just keep loading it into CosmosDB. So now, if we go to our CosmosDB account, which can be found here, go to Data Explorer, head over to your collection, go to your documents, and now you're seeing all these populations all the fields being populated. Now, if you're wondering what ID is and all those things, again, you should reference the video that I mentioned that is in the description to give you a quick introduction of how CosmosDB works. So as I continuously refresh this, you'll see that the data is being ingested and more and more. Over here, it just keeps loading to Cosmos. I'm just going to leave it as is for maybe 30 minutes to an hour so we can get a lot more data points. And then from there, I'll be showing you how we're going to be creating our virtual network and then our Databricks workspace. So now we've waited quite some time, and if we refresh this data, you'll see that we have quite a few data points now. Our application is still running, and we're just going to continue it for it to run, and it has no real impact on us. So what we're going to be doing now is we're going to be creating our virtual network. Now, why are we creating this virtual network? One, a lot of times when you're working, we know with these Azure resources, you want to isolate some of these resources. So for example, you only accept certain IPs, or you want to configure certain firewalls. And this is more so from a privacy perspective and from a security perspective as well. And this would allow you to see how we can introduce something called, a VNet injection and introduce an Azure resource into a virtual network. And it also allows us to see how we can utilize things like service endpoints to allow Azure, CosmosDB, and Databricks to basically talk to one another in a safe and secure way. So this is why we are going to be creating a virtual network. If you head over to your Azure portal now, go on virtual networks, create a virtual network. We can choose the same resource group that we've been using. The instance details we'll just name it virtual network, Databricks, Cosmos. And the next thing that I do want to stress is this region area. And this region has to be the exact same region you've deployed your CosmosDB service in. And this is because virtual networks do not span regions, but they do span within a region. So within Canada Central, all the availability zones within Canada Central will be able to recognize this virtual network. But if you were to deploy, let's say, a Databricks workspace from US West 2 and try to do a VNet injection into this particular virtual network, you won't be able to do that. This is because it won't recognize it, because the virtual network would not be within the same region. So this is extremely important. This is extremely important that you select the exact same region and stay consistent throughout this whole process. So next is the IP4 address. So we can write, this is the address space ranges that the virtual network will be able to use. So we can write 10 to 016, perfect. And the subnet, we can just add subnet address range of, let's edit this, and we can write 0.20024. So within a virtual network, there's something called subnets, which are, maybe you can think of them as virtual networks within a virtual network. And this allows for more isolation. So you can have maybe multiple different Azure resources spanning multiple subnets within a particular virtual network. So we can save that over here. And next we can proceed to security. We can go to view and create, and give it a few minutes for it to create. And I'll be back when this has been created. You'll see now that we have created our virtual network, but there still has to be one more thing that we have to do. So if we go on over to address space here, and with this address space, what we're gonna have to do is add another additional address range, and this address range will be used to create the two subnets, the public and the private subnet, which is the result of what happens when we are trying to do a VNet injection into this virtual network when we're creating our Azure Databricks workspace. So from this case, we'll add this particular address space here, and we'll save that there. And now, if we head over to our Databricks resource and create, now we can list our resource group, which is CosmosDB Databricks. Our workspace name will just be CosmosDB Databricks demo. And the region, like I mentioned, has to be the same region we've been consistently deploying our resources in. So this will be Canada Central. Pricing tier will be premium because we want to use the Partner Connect for Power BI to facilitate that. when we're into our Databricks workspace. So now we go on over to networking. So when we're actually deploying Databricks into a virtual network, it will create two different subnets. Well, the first subnet will be a host subnet, also called a public subnet, and the other one will be a container subnet, and this is a private subnet. So if you want cluster to cluster secure cluster connectivity with no public IP, this will create two private subnets, one host, one container. In our case, we just simply want to deploy it or inject it into our current virtual network. So we're going to deploy Azure Databricks Workspace in our own virtual network that we just created. The virtual network here will be what you see here, which is a virtual network Databricks Cosmos. Here we'll just write public subnet, private subnet, and now the address range will be the following. Here, and this is what this is using is from the address space that we created. From the address space that we created, it will take these ranges and assign it the public and the private subnet respectively from those particular ranges. Now, allow public network access. For this time being, we're just going to enable it here. And if you have any NSG rules, let's say you have any firewalls or to prevent, or certain rules to prevent or allow particular traffic, then this is something that you can also allow here. And for our case, we're not going to use a private endpoint. We're going to be using a service endpoint. But if you want to learn more about private endpoints, and if this is something that interests you and how to leverage private endpoints in this use case, please do let me know, and I will be more than happy to create another tutorial on that. So if we go on advanced, next tags, review and create, this is going to be validating, and then now we're going to be creating the Databricks workspace. So let's just wait a few minutes. This is going to take a few minutes for it to deploy, and in the meantime, we're just going to wait for it until it's done. So now that we're waiting for our Databricks workspace to be deployed, now one thing that we have to do is we have to create a service endpoint for our CosmosDB. And what this does is, in essence, it restricts access to creating a service endpoint would restrict access to past services to traffic coming from our specific VNet. So what this allows CosmosDB to do is to basically accept traffic to the public subnet available in our Azure Databricks workspace when we created it. So if we go on our virtual network here and we go on to our subnets, head over onto our public subnet. This is the public subnet that was created when we deployed Databricks or when we created our Databricks workspace. And now you see the service endpoint here. And as I mentioned, it allows traffic to specific Azure resources from our virtual network over this thing called service endpoint. So what we have to do is select that service. So in our case, it would be CosmosDB. So all we have to do is find Microsoft Azure CosmosDB, select that over here, and save it. And this is all we would have to do to create that service endpoint between CosmosDB from the resource that we had to our Databricks workspace. So now that we've deployed our Azure Databricks workspace, what we want to do now is launch the workspace and install all the necessary libraries that we're going to need for us to facilitate that connection, and then also create some configurations in our cluster to basically create that connection to our Azure CosmosDB resource that we've had. So we're just going to be waiting for it to authorize. This is the first time we've obviously gone to this workspace. We're going to cancel all that out, and we're going to create a cluster. So if you go over here, create a cluster. I'm going to label it, testing cluster Cosmos, and I'm going to use a single node for this purpose. Nothing too crazy here. Going to keep it the same. Also going to have maybe a 20-minute timer for termination. And this is the very, very important part, and this is the configuration aspect. So in the configuration, we're going to have to add two things. One of them is a Spark MongoDB URL, and this would be here in the config. And following the URL for the output, we're going to need basically the connection string that we used before to connect to our CosmosDB account. So if we go back to our application, and we head on over to our connection over here, we can copy this, and the URL would be that. And then we can also maybe do the exact same thing for input and do that. And this is very important for us. Now what we're going to have to do is we're going to have to create the cluster. Once the cluster has been created, we're going to install the libraries that we're going to need for the connector. And then we're going to create a notebook and facilitate that connection. Now that we have created our cluster, we can now create or install the libraries that are needed for us to basically connect to our CosmosDB. And this would be the mongo-spark connector. So if we go on libraries here, install new, I go to Maven, search packages, this will load, and we're going to search for Mongo. Give it a second for it to load. This is the mongo-spark connector, and this is what we're going to need. So we select this and we install it. So while this is installing, this will obviously have to restart this particular cluster with this installed. And the data that we're going to need is basically this whole information here, which is the coordinate for when we are creating our application in our notebook. We're going to reference this particular connector to facilitate the connection. And our connection will actually loop back to our config and reference the connection strings that we labeled there for it to create the connection. So this is pending, and I'll be back when it has when it's all done. Now you see that our library has been installed in our cluster, and now we can begin to write some introductory code to actually facilitate that connection to our CosmosDB resource. So here we can write CosmosDB demo testing. We're going to use PySpark, and the cluster is going to be the one we just created, and we can write that. We can go over here. That's great. So now what we can do is we can write from PySpark SQL import SparkSession, and then the database name will be the testing Cosmos, and then will be the collection name will be the testing Databricks Cosmos. And then we can write, or we can execute the new SparkSession. So let's just run this first. Okay, great. So now we can write SparkSession builder app name, and we can write testing app, and this will be .config, and this is where we're gonna specify where we're gonna find the actual library that we just installed. So this would be packages or MongoDB, and I think what we can do is just paste it because we've copied that before, right? And then we can get or create, and this should work. Awesome. And now if all works smoothly, what we can do now is just pass a read format into our like a data frame. So we can write spark read format MongoDB Spark SQL default source, and this will be option data base, and this will, we're going to reference the database that we have created here, the database name. And we're going to write option collection, and this will be the collection that we had earlier, and we're going to load it. So if we load this, we're going to see that the Spark job has run, and now this is the moment of truth. If we write df show, you'll see that this is the data that we had in our particular database in CosmosDB. So this is a really, really cool way to illustrate and show that. So now you might be wondering, okay, we have all this data, and now it's configured in a way where we can maybe do like large scale analytics on it. One thing to note though, that if you're trying to stream this data incoming into this database, you won't be able to, just because this current MongoDB Spark connector doesn't support that currently. But it's something that maybe will change in the future. But now if you go on to, let's say new, or not new, but let's just go on over in the bottom, you'll see that here it says Partner Connect. So if we click on that, right, and this will show you where we can actually deploy all, or maybe the data, right, that we were working with into maybe our Microsoft Power BI. So I want to go back to our notebooks for a second. Let's go back over here. Let's go to our notebook here. Okay, great. So let's say we want to use Partners Connect, right? Partner Connect to connect to Power BI and visualize this information. And one way we can do that is we can actually store this data frame here into a Hive Metastore. So let's do that real quick. So if you write df write save as table, and we can write Power BI table, right? And so let's save this. And once we save this, this is actually going to store this table here into our Hive Metastore. And it's also going to be in Delta format. So that's something we should also know. So if you go on data here, you'll see that default here, it's actually stored into our Hive Metastore. Now, why do I mention all this? Is because if we go to Partner Connect and we go to Power BI and the compute, it would be the testing. This is basically asking, where am I going to be finding this Hive Metastore so I can display into Power BI? And the data would be in this particular cluster, because this is where we saved into our Hive Metastore for that table. So let's download this connection file. So now you see that in the downloads, it actually provides you a connection file in Power BI. So if you click on this, right, what it will do is it will launch Power BI with this, with all the configurations of how to actually connect to that Hive Metastore in your cluster, right? And it will establish a connection. It will authorize you through Active Directory, make sure that you have all the appropriate permissions. And now, once it does that, you can go on Hive Metastore, the default database, I guess. And then from there, you'll see the table. And if we click on this table, you'll see that it's the exact same table that we were working with. And now what we can do is if we click on this, double click on it, load. And now everything that we have written into that Hive Metastore from that data frame will be found here, and we can start creating visualizations from the data we just imported using this Partner Connect. So that's a really cool feature. And I think that it really showcases the power of how you can streamline a lot of your analytical workflows. As well as it really showcases the power of how all these different resources integrate with one another. You know, we started off going into our, we started off with our Python application, created the resources, did a VNet injection on the Databricks workspace, created the configurations of the notebook, used the Partner Connect to connect to Power BI, and now you can create amazing, stunning visualizations. So I really hope you enjoyed, and this was very informative for you. If you really liked the video, please like and subscribe, and leave a comment and let me know your thoughts on what maybe some other projects you'd want to see tutorials on using Azure. And thank you so much for watching, and have a great day.